Hello and welcome to the session. Let's continue our discussion for list interface. So it is one of the interface in collection framework, one of the very widely used and very simple to understand. So let us understand the list interface. So list interface provides useful methods to add an element at the specific index, remove, replace element based on the index, and to get a sublist using the index. So the list interface is kind of similar to an array, but certain advantages are there. Now array list and linked list are implementation classes of list interface, and both are not thread safe. So let us see array list. Now if you see here, list interface is implemented in array list and linked list. Now it is a mechanism to store elements in a certain manner. It is more like array with dynamic length. So it is more like an array. So what happens is, when we declare an array in Java, we have to specify the size, and once we specify the size, the array length remains the same throughout the program. We can change the individual element, we can set it to null or 0 or -1 or whatever, but then the array size is fixed throughout the program. Now that can be a problem for many places, at many places. Why? Because you want to increase the array size dynamically based on your condition. So in order to address that problem, we have this list interface. So if you see, whenever you declare an array list here, you will be given some specific size of the array list. Let's say it's called as capacity, initial capacity. Now this varies based on certain versions of Java, but consider the value will be, let's say, 10. So you have an array list of strings. So the memory will be assigned for 10 locations of type string. Now let's say you start filling the elements. So you are up to seventh element, and now once the capacity is full, let's say 10 elements are added, then automatically the size of this array list will be incremented by certain percentage, let's say 50% dynamically, so that we can add additional elements. Now as a programmer, we need not to worry, because this happens in backend, and this is how the size of the array is increased dynamically. Size of the array list is increased dynamically. Same thing applies for, if the number of elements are reduced, the size will be reduced dynamically. That is called as capacity. Now capacity is different and size is different. Size is basically total number of elements actually are in use, that is size. Capacity is basically how much memory is allocated for that particular array list. Now normally we don't deal with capacity, and basically it happens in backend, so we need not to worry much about it. Now yeah, so let's see with an example. So I have this class array list. Now if you see, this is how the declaration of array list happens. We need to use this less than and square, less than and greater than bracket. So this is how the array list declaration happens. So left hand side, if you see, array list of string is whatever name is equal to new array list of string. So less than, greater than bracket, and this curly bracket, this round bracket. So this is how the definition happens for the array list, or for that matter for subsequent collection framework, we will be using this kind of notations. Now this is looks like similar to array, but if you see here, when I define the array list, I have not specified any size. Why? Because I need not to specify the size, because the size is dynamic. Now if you see, this array list is a basically a class in utility package. It's basically a collection framework. Now it is a ready-made class, so it has certain ready-made methods which we can reuse. Now if you see, dot add so now here if you see, I have started adding elements into the string array list. Basically you can consider this as you are filling the array. But now you see, now here I'm printing the array list here, and now if you see, I have additional method called as remove. So if you see, I can remove the element as and when I want. Okay, I can remove it by the element itself. Let's say it is a string, or I can remove by particular index. So what happens by remove, when I say remove, now if you see here in these 4 lines, it has added 4 elements. So the size of the array list is 4 at the end of this line. Now when you remove this, that means these 2 elements will be removed, geography and English. So the size of the array will be reduced to 2 elements. right? So the size will be reduced to 2 elements. So that is basically the addition, add and remove method. Now, yeah, full array list after removing 2 elements. Now how do you get the size? You can say subject dot size. Now how do you get the nth element? You say the variable dot get. So this is slightly different from the array. In array, if you want to uh, get an element having a specific index, you say you give a square bracket. Here we have a direct method called as get method. So this is the change in array list. So if you see, array list is a class basically, and we are just exploring the methods in the ready-made class array. Okay, now subject dot contains, so it will check whether it will basically search whether this particular element exists or not. Okay, so it will be basically true or false. Now subjects dot is empty, so it will check whether the size of the array list is empty or not. Okay, similarly we have get 0. So I have one method called as set. Okay, so set is basically replacing the existing value. Set method is used to replace the existing element value. So value of the 0th element will be changed to Russian, and then I will say get 0. So I will expect the latest value to be there. Now how to insert an element? This is interesting. Now if you see here, in array, the actual array, we cannot insert any element. Okay, we have to shift the elements and then we can insert probably, but then dynamically we cannot insert any element. So that is the advantage here. If you see add at index 0 Spanish, that means the 0th index element will be Spanish and rest of the elements will be automatically shifted. So there other the remaining uh, elements index will be automatically incremented by 1. So that is the change here. That is the advantage here, that you can dynamically insert the element and you can remove, you can replace, and you can add. So multiple things you can do. Okay, so get 0 again, I expected the value should be Spanish. Now clear subjects dot clear. This is a good method. So this will basically clear the array list elements. So basically the size will be again reset to 0, and all the elements which were there earlier, those will be wiped out. The memory assigned to those elements can be reutilized. So clear is basically clearing the array list. This does not mean that the array list variable subjects will be set to null. It is not like that. It is basically wiping out all the elements. So subjects will not be set to null. Okay, now let us run this first and just see the output. Okay, so full array list is this one. Then array list after removing 2 elements. So the size is basically 2. Now nth element is science, contains a specific element. Yes, it does not contain. Is it empty? No, it is not empty because there are still 2 elements. Nth element is Russian, and then I have inserted Spanish. So array list size after clearing. So size will be set to 0. As we discussed, size will be set to 0. Now this is basically array list class and different methods. Now array list of primitive data type is not allowed. Okay, this is the slightly disadvantage, I would say, but it is a correct thing. Why? Because if you see the array list here, okay, the array list which we have discussed here, this is of type string. Okay, in this case this is the array list of type integer. Now what it means is, in an array list we can have an array list of non-primitive data type only. What is primitive data type? Primitive means int, long, double, float. These are the primitive data types. Since Java supports it, Java allows it, but in the array list, in the collection framework, we have to use the wrapper classes for that. So that is why, as we have discussed earlier also, these wrapper classes are helpful in collection framework. So if you see, in this case, I have array list of type integer. Similarly, you can have float, double, boolean, character, other types of primitive data type also. If you want to just explicitly check what happens if I mention the primitive data type here, it is basically compilation error. What it says, type argument cannot be of type primitive. So primitive data type of array list or linked list or any collection framework is not supported. Okay, the one more change here is, if you see, this is grayed out. So instead of this, if I do it like this is also correct. Okay, the declaration, the definition, what I'm doing on the right hand side, it can be generic also. What matters is what is there on your left hand side. Okay, but for the sake of good coding practice, I'm mentioning here as integer. Now there's one more thing what we need to see is, if you see here, left hand side is array list, right hand side is an object of array list, left hand side is list, and right hand side is an object of array list. Now the example what we have seen here is array list on the left hand side, also the array list on the left hand side. Now what is this? So if you see, we have seen that upcasting example, or what is the thing here is, on the left hand side, it is a variable of an interface. Here left hand side is an variable of a class, but right hand side should always be something which is an object of a class only. So since array list is a class, so it takes, so right hand side should be always the object of any class. Left hand side we can have interface, we can have object of a class also. This, so sometimes in some developers may use this kind of structure, or very general way is you go for this example. This is correct, this is widely used, but I have just given an example of this one also. Left hand side can be a variable of a class. Here it is, left hand side is a variable of an interface. Okay, now let us see what are the other things in array list. So let's say you have an array list of 4 5 items. So how do you iterate through array list? Okay, how do you go to individual element, and if you want to process, let's say, employee data, student data, then how do you do it? So this is basically iterating using for loop. So you can get a size here, and with a just simple for loop you can iterate, and you can say cars dot get n, so you can iterate through individual element. Now this is using for loop, this is using advanced for loop. So if you see the cars, if you see the cars here, the cars array list is of type string. Okay, so what I need to do is, in the enhanced for loop I need to iterate on individual element which is of type string. You can take whatever type of argument you have, integer, boolean, character, float, other things. So I've taken example of string, which is very simple to understand, and I am just processing it. For now I'm just printing it. Now there's one more way is using iterator interface. So remember, we have seen iterator is the parent interface for all the collection framework. So we can have iterator here. Left hand side is a variable of iterator interface, and if you see cars dot iterator. Okay, so array list, what is cars here? Cars is basically a variable of array list. So cars has this array list class provides a method called as iterator. So iterator is basically an iteration mechanism through which we can iterate through individual elements, and this is quite it is quite largely used across the Java community. So we will also look into it. Now we will iterate using iterator class variable and using a while loop. So what is this iterator has next? So once it iterates through number of elements in an array list or whatever type of collection framework, it will basically check whether is there any next element present. So if it is pointing to the last element, and when you say iter dot has next, so it will give you false. So this is also one of the good mechanism to check whether any element is any remaining or not, and if it is remaining, then only you go and you say iter dot next, so it will give you the next element in the particular array list or collection framework. This is also one of the good approach. Now using lambda function, So Java Lambda function is also becoming quite popular. It is introduced from Java, I think 1.8 version onwards, and it is also easy to understand. So cars dot for each. So if you see cars, so this array list provides a mechanism to iterate through elements using for each, and you need to use this lambda function syntax, and you will print system dot out dot println. Now this looks very simple and bit clean to process individual elements, so we will also see that. Okay, so let's just run it and see what happens. So 1 2 3 4 5 elements are there. Right, so using each iteration mechanism, I'm able to iterate through the element and able to get individual element. Okay, so some other extra points about list interface. List is an ordered collection, or it maintains the index of the elements. Now we have seen that whatever we have added the numbers here. Okay, in the earlier example, we have added the subjects here, and we can access the subject by some index. So whenever any element is getting added, an index for that particular element will be automatically stored, or it will be available. Or in other words, in the list, array list or linked list, it is an ordered collection, or it maintains the index of the element throughout. Now list index starts from 0, just like an array. It allows you to add duplicate elements also. Okay, so these are certain additional features, I would say. This will be comparable when we see other interfaces like set and hash map and all. So there, this particular features matters. So I'm just mentioning here that it allows you to add duplicate elements. So if you see here okay, let's see in this example. So here, if I say once again the same statement, add Toyota, what will happen is this is basically uh, will allow you to add duplicate elements. So let's just run it once and see. Okay, so if you see, duplicate elements are allowed to get added. Only thing is the index for individual element will be different. So this is allowed. Adding duplicate element is also allowed. It allows you to add null elements. So if let's say here, instead of Toyota, I can add null also. Okay, so this is one of the feature. If you see in other collection framework interfaces, null elements are not allowed. So there is a reason for that, but we will see that later. You can access any element from its index. Searching for elements, we can use this dot index of method, and it starts from let's say index 0. So we can search for an element also using this dot index of certain thing. I think you might have seen it here. Okay, so let me just put it here. Index of, and I will say, for example, Spanish. So what will happen is it will give me the index of nth element. Let's just run it and see what happens. Index of the element, which is 0, because Spanish will be at at index 0. So this is correct and this is good. Right, now let us see another class, which is linked list. So linked list, if you see here, linked list has also implemented this list interface. But if you see in earlier picture, the overall picture, linked list is basically implementing this list interface and DQ interface. Now we will come to the interface queue and dequeue in later sessions, but for now we'll just focus on linked list. Now what is linked list? Linked list, it implements list and dequeue interface. It is an ordered collection, or it maintains the index of the element. Okay, list index starts from 0. It allows you to add duplicate elements. It allows you to have null elements. You can access any element from its index. Searching of elements starts either from index 0, or so it has additional method called as last index of. Okay, and we can use it as stack or queue. So for now, until now, array list and linked list sounds similar methods and similar feature. Now what is the change? Okay, so here if you see in the linked list, each element may not be stored at an homogeneous consecutive memory location. Each node maintains the reference to previous and the next element. Now this is a change. The name itself says linked list, so it maintains a link between current element. It maintains a link from the to the previous node and also to the next node. So if you see here, actual node value, and every node is maintaining a link for previous and the next. Okay, this is maintaining a link to the previous and link to the next element, and so on. Obviously the first element, the previous node reference will be zero, will be none or null, and the last element, the previous node, uh, the next node reference will be none or null. Now what is the, let us see with an example here. Right, so I, instead of array list, I have used linked list. So this addition methods, these are all remain the same. It has these additional methods called as add first and add last. Add last. So this is a slight change from the array list. You can add any element at the first or at the last, right? Get first, get last. Obviously you can get the first or the last element. Right, add all. So add all, so if you see here, I have this linked list called as family another, and I have this linked list called as family. So what I want to do, both are of the same type, linked list string, both are of the same type. So what I want to do is I want to add this complete linked list into the earlier linked list family. So what I will do, family dot add all, family another, and I can say family dot remove all, family another. So that is also possible. So I can directly remove a bulk of another linked list itself directly. Okay, now linked list example we have seen. Let's just run it. Okay, same example also here, also the same thing, just like array list. On the left hand side, if you see, since I can have an object of a variable of linked list itself, of type linked list, or I can use a list interface, and right hand side is always the object of a class. Okay, so left hand side interface, right hand side object of a class. Both things, these both things are correct, but normally people or developers would prefer to use an interface variable than the actual class variable. Both are correct. Both can solve your purpose in a certain way, but this is what is preferred most of the time. Okay, let's just run it and see if it runs. Right, so it is supporting now linked list after adding another full list. Okay, grandfather, cousin, brother, so that is also added here. Grandfather and cousin brother is also added. So other features like iterating and adding, individual, removing, these things, these all remain the same. No change in that. Okay, now you might ask, like, what is the advantage in, maintaining an extra link between previous and next? Okay, so that we will see when we will look into the difference between array list and linked list. Now array list maintains index of the element, so memory consumption for the same is low. It maintains the reference to previous and next element, so memory consumption is more or almost double. Okay, uh, here it maintains an index, here it maintains a reference to previous and next. Okay. Now, what is the advantage in having a reference? Now, what happens is, let's say you are maintaining a linked list and you are maintaining an array list for the same set of data. Now, what happens is, let's say, uh, okay, okay, let's say that you have 1000 elements in an array list and you have 1000 element in a linked list. Now, for some reason, you want to insert some data into the array list at index 50, and the same reason, same thing for linked list also. You want to insert the data at index 50. Now, in array list, what happens is whenever you insert an element, it will be inserted, but the remaining element from 51 to 1000 will have to be shifted to +1. Now, for 1000 element, it is still okay, but you have, let's say, thousands of records. So changing the index of all the elements from 51 to, let's say, 1 lakh is memory intensive operation and time consume time time related action. It takes a lot of time and lot of memory resources. Now, what happens, the same thing if you do in the linked list. In the linked list, what we need to do is we need to just insert this element and just change the link of this node and this node. So this nodes link to the next, this one will be cut and it will be pointing to this. And for this node, the previous will not be pointing to this, but previous will be pointing to this. Okay, so this this will save lot of memory, lot of time, and lot of resources. So this is the advantage in the linked list. The If you have a lot of insert operation or if you have a lot of delete operation, linked list is preferred compared to array list. Okay, so searching an element with index, hence search operation is fast. If you see, the searching an element, it needs to traverse through all the elements using previous and next reference. So hence this search operation is a bit slow. Okay, why? Because it is traversing, and here it is not traversing, it is based on the index. Now, insert delete elements needs huge time and memory consumption, and here if you see, it is very quick and memory effective. So that is the advantage when using linked list. Now, it can be used as a stack and queue. This is also both the same. It uses array internally, so element must be stored together. As we discussed, array list is basically an array only, where elements are stored in an array, and array size, so multiple arrays will be added so that it maintains the elements, but it is basically an array only. Now, in linked list, it is not using any array, so individual elements can be stored at a different location. So it may not be at a homogeneous location. Now it has this method. So there are some methods like add, remove, replace, and those things. Here there are additional methods like add first, add last, get first, and get first, get last, etc. So little additional methods are here. Now array list, it is better for frequent data storing and accessing operation. So you store the data in an array list and you just search for it. Now those kind of operations are good when we go for array list. Now in linked list, when you want to frequently change the data, you want to frequently insert, delete, or maybe even update the data, or remove the data elements and all, that time linked list is preferable, because that time linked list will take very less time, very less resources. So these are the few points for the difference between array list and linked list. It is also a very good interview question. So please go through it and try to correlate it. So we will see the subsequent topic in the next session. Thank you.